Okay, so this is 2020 November 1HR question 22 from the IGCSE Maths qualification. Let's dive in. So first of all, take a read of the question, pause the video. Okay, so we're asked to find the area of the shaded region. Is there any way we can find the area using a formula? Let's look at the shaded region. Right, well, it's not any shape that we know a formula for, so can we break it down into shapes we do know how to find the area of? Okay, so one way you might have done that is by splitting the shaded shape like this. What shapes are those? Well, they're a rectangle and a triangle. What do we need now? We need the area. How can we find the area of these two shapes? All right, so the rectangle, we've got this 10 centimeters, DE. We've got this 10 centimeters length here. And what about the length? What else do we need? We need its length, don't we? So we need this. How can we find that length? Do we know it? We don't. So let's find it out. So, it seems like it's going to be a bit hard to find. It needs to be spanning, going across the shape. So we can break it down. Let's think. All right, so perhaps if we go back to the original shape, if we join these lines like this to make a rectangle, let me call that P and Q to talk about it more easily. Introduce notation. Okay, so what do we know about these shapes? Well, why do we know that this is 10 as well? Right, because we've got a regular octagon, all sides the same, length, that's 10. Okay, it seems you don't know this length here. How can we find it out? Well, is there anything we know about this shape that we're looking at? This shape over here, EFQ. Let me just make a new shape over here. So EFQ, what do we know about EFQ? Well, we know first of all, what do we know about anything about it? Do we know, no, this is 10. Why do we know that? Right, octagon again. Anything else we know? Right, we know this angle is 90. Can we work out anything else about the shape? Well, what can we say about any information we haven't used yet? Well, we haven't used something else about the octagon. What haven't we used? Right, we haven't used its exterior angles, all right, i.e. its angles at all. How can we use that to help us? Let's have a look. So if I extend this length along here, what do I know about this angle here? Oh, well, I've got a regular octagon. I know this is going to be 360 divided by the number of sides, 8 in this case. So that's going to be 45 degrees. So therefore, if that's 45 degrees, what can I say about this angle here? Let me put another color, so red. What can I say about that angle? Right, it's going to be 180, angle on the whole line. Subtract 9, subtract 45, so it's going to be 45 as well. Let me draw that on a larger shape, 45 degrees. So we're interested in this shape, 45 degrees. What else can we find out about that? What are we interested in again? Right, we're interested in this length QE. That length there. Let me just draw it here. That's what we're interested in. So how can we find that out? Let's look at our larger diagram. What do we know about the triangle? We know the hypotenuse is 10 and it's got 45 degree angle and 90 degrees. Right, it's a right angled triangle. How can we work it out then? Well, what do we know in relation to that 45 degree angle? What can we say about the side? Well, perhaps we could say that. Why are we going to use sine 45? To help us with the side, right, because we've got a side which is opposite the angle. So sine 45 equals opposite, in this case question mark, over 10, hypotenuse. Great. So question mark equals 10 sine 45. Do I have to leave it like this? Don't, do I? I can use my calculator and get an actual value. What does it end up giving us? 10 times root 2 over 2, if you prefer not to use a calculator, which gives us, overall 5 root 2. So we have 5 root 2 for that question mark length. 5 root 2 was 5 root 2, and therefore we get, why is it the case also that this is 5 root 2? All right, because you end up with exactly the same shape, just another copy of that 45, 45, 90 degree triangle, exactly the same size. Cool, so that's 5 root 2 and 10. Let's write that on our rectangle. So overall, we've got 5 root 2 and 10 length. So 5 root 2 plus 10 plus 5 root 2. How can I simplify that? Right, I can just write it as collecting the surds, the root 2 terms and the number 10 plus 10 root 2. So overall I've got that length. Now, why do we even work that out again? Ah, yes, it was to work out the area. So, therefore we can say the area of that shape. What can we say about the area? This blue one, let me do it like this. So area of that blue shape, what does it give us? Right, we just work out base times height. So 10 times 10 plus 10 root 2. You might be thinking, oh, look, I'm going to have to just deal with surds this whole time. Why do we actually not need to deal with surds this whole time? Why can't we just use calculators for these calculations? Right, it's because it says correct to the nearest centimetre squared. So we don't need to give exact answers. It does not say give your answer in exact form. So we can actually just put answers like things like this in the calculator when it comes to the time to do it. Right, so we've got the area of this blue shape, which we can then put in a calculator. Why is that not yet finishing the question? Right, we've got something else left to do, haven't we? So we've looked back at the question, we think, oh, we're trying to find the area of the shaded region, the overall area of the shaded region, ACDH. We've still got left another region, haven't we? ACD. Now, what do we know about that shape? Right, it's a triangle. How do we figure out its area? Well, we need a base and a perpendicular height. So do we have a base? Right, we have a base, don't we? We have this base here. So we've got this base, and let me in fact draw another image of that shape, so it's easier to see what's going on. So ACD, we've got this shape here, not drawn that well, but let's do it anyway. So that's going to be 10 plus 10 root 2 again, as it's another side of that rectangle. 10 plus 10 root 2. What else are we interested in for the area of this triangle? If we consider this to be the base, right, we're interested in the height, right? Not just any height, the perpendicular height. The height is perpendicular to the base. So we're interested in that height there. Now, is there any way we can work that out? How can we work out that height? You might have noticed, actually, that if we look at this height, what have we just constructed, this perpendicular height? Right, we've just constructed, again, the same 90-degree triangle, 45 degrees, as we had before, just down below. So, in fact, this triangle simply has height. What height was it again of that triangle? It was just, it was question mark, wasn't it, with this question mark? Oh wait, how do we know that it's actually the length of the question mark? Well, what do we in fact know about this triangle? 45 degrees and 45 degrees, just as we saw here, 45, 45. Therefore, what type of triangle is it? Right, it's an isosceles right angled triangle. So in fact, this length, what can we say about it? It's the same as the other length, question mark. So that's 5 root 2 as well. Let me just write that here, 5 root 2, 5 root 2. And therefore the height of our new triangle, which is also the height of that same, length of that same side, that's also going to be 5 root 2, is it not? So 5 root 2 for our height, exactly the same triangle. So 5 root 2, write that there. So overall, how can we get the area of this? Right, so we're going to need to do half base, 10 plus 10 root 2, times height, 5 root 2, and that will give us the area of this green triangle. So let me say area triangle equals that. Area of, what was it? Rectangle was 10 plus 10 root 2. Tangle equals 10 plus 10 root 2. What do we do to get the overall area of these shapes? Right, of the shaded area, we're just going to subtract them, aren't we? So let's do that. Sorry, add them together, forgive me. Add them together to get the total area, the blue and the green. So let's add these together. Total area equals, and what do you want to use? We want to use our calculator. So 10 plus 10 root 2, just working on my own calculator here, and add that to half 10 plus 10 root 2 times 5 root 2 times 5 root 2. What does that overall give us? It gives us an answer of 326.776 blah blah blah, and that's our answer, right? No, we want to correct it to the nearest centimetre squared, as we're told. So nearest centimetre squared, So we say area equals 327 centimeters squared. Right. So that is our answer to our question, area in centimeters squared. That was question 22 from the 2020 November 1HR question paper, Edexcel IGCSE Maths. Thank you for your time.